Okay, so I just wanted to do a little more with that Celsius formula. The Celsius formula said C, Celsius temperature, is going to equal 5/9 times Fahrenheit minus 32. So what if you said the Celsius temperature was 26 degrees? Okay, then you would put the 26 in here. And you can solve this. You would multiply by 9/5 on both sides. So you get, I don't know, whatever 9 times 26/5 is. That would equal Fahrenheit minus 32. So then you could just add the 32 over. Let me put it over here. 9 times 26/5 plus 32 would equal the Fahrenheit temperature. Now if I do that on the calculator real quick, what do I get? 9 times 26 divided by 5 plus 32. It's about 79 degrees. Fahrenheit is going to be about, it's 78.8. Okay, degrees. Okay, so I just wanted to show you that process. So if you're given the Celsius, you can in fact find the Fahrenheit. You have to solve the equation. Well, now with inverses, we are able to get an equation, so we don't have to do that every time we want to change from Celsius to Fahrenheit. Okay, now on to what this video is supposed to talk about. Verifying two functions or inverses. There's a process to this. And so this is how you do it. If f and f inverse are inverses, then here's the rule that they have to follow. F compose f inverse of x, which is the same as f of f inverse of x. It has to equal x. And it has to be true if you switch it the other way. So if you have f inverse compose f of x, which you could write as f inverse of f of x, that also has to equal x. Okay? So now over here we have two functions. So if I were to compose them, call this f and this g. So say, and they're both in terms of x, f of x and g of x. So let's say I go f compose g of x. So we did compositions in another video, but what we would be doing is we would be putting the g function into the f function. So I'd have 4 times 1/4 x. And sure enough, that's just going to equal x. Now if I switch it and go the other way, g compose f of x, then I would take 4x and put it in there. So I'd have 1/4 times 4x. Now this function is not extremely exciting. You just have one operation going on in each of them, but you do get x. If you think about it a little bit, here in this function, I'm going 4 times x. And how do you undo 4 times something? You divide by 4, right? Okay, so or 1/4 of it. So that's why they're inverses. You know those tricks where they say, hey, think of your age and add 10 and multiply by 2, and you know, they give you a bunch of steps and then you tell them the number and then they can tell you your age. Well, that's all based on inverses. Everything they told you to do, every operation they told you to do, they undo it and then they can find your age. Okay,